Hi, I'm Evan Boyd.
Hi, my name is Chrislyn.
Hello, my name is Walid Sri.
Hello, my name is Brittany Staley, and this is Maze Haze. The U.S. consumption of fossil fuels is at an all-time high. According to the Energy Information Administration, the U.S. consumed approximately 141 billion gallons of gasoline in 2015 alone. Fossil fuel use has a negative byproduct of carbon emissions. This has become a major problem globally because carbon emissions are the largest contributor to global climate change because of their greenhouse effect on the planet. Because of this problem, the U.S. has searched for an alternative. One alternative that they found viable is biofuel ethanol. Ethanol is produced via corn. This was found to be better as corn is a renewable resource that can be grown in the United States, reducing the U.S.'s dependency on oil countries, as well as producing little to no emissions when burned in a car. Because of ethanol's viability, an act was passed in 2007 called the Energy Independence and Security Act of 2007. This act mandated an increase of biofuel addition to gasoline from 34 billion liters, the projected amount for 2008, to 136 billion liters by 2022. This act has increased the production of corn for biofuels dramatically. This production of corn has taken place mostly in the Midwestern United States. This has caused a chain of reactions. One of the problems of these chain of reactions is that most of the food produced for the USA is produced in the Midwestern United States. This has resulted in a food production competition versus biofuels or corn made for ethanol. Because of this increased production of corn in the Midwest, researchers have done studies. One ecologist, Mehaffey, states that there is a growing concern that these changes in agricultural practices will result in an increased ecological and economic cost. If the ecosystems of the Midwest are unable to absorb these changes, there is an increased risk to biodiversity. She goes on to talk about some of the risks to biodiversity and ways that it would affect the biodiversity, as well as risks to the human population in that area in forms of air pollution and other health effects that this form of agriculture would have. With that in mind, biofuels in its current production process has some more flaws. According to a study by scientist Timothy Searchinger, the production of biofuel use, instead of producing a 20% reduction in emissions, nearly doubles greenhouse gas emissions over 30 years and increases emissions by 50%. This is a major problem because the use of biofuels was supposed to help not only reduce our dependency on fossil fuels, but also reduce our carbon emissions. When the whole process of producing biofuels, from the production of corn, the growing of it, to how it gets to our car, and that whole process of refining it, the carbon emissions are vastly greater than that of the process of fossil fuel use. This has become a major problem, and the current production of biofuels has some major flaws that will be addressed, that need to be addressed.
Biofuels have escalated quickly over the last several years. In 2000, around 10 billion liters were produced, and then in 2012, around 80 billion liters were produced. So the increase in demand for biofuels is greatly getting higher over the years. Where we're headed with these biofuels is we're going to try to transition over from first generation to second generation and third generation. And what that means is that instead of us creating these biofuels from crops such as corn and sugarcane, we will be creating them from things such as waste biomass and certain animal fats, certain vegetable oils, certain things like lignocellulosic and algae, and that is going to help with the downside of first generation biofuels, so we're not going to have the same land use problems. It's going to cut carbon emissions and greenhouse gas emissions. We won't have the problem with food price rising in corn, several things. So it's going to be a more environmentally sustainable option to fossil fuels and even to first generation biofuels. And one of the biggest holdbacks that we have is funding. So where we need to be and where we need to go is we need to get policies that allow us to start mixing more of these biofuels in with our regular fuels, and that will show consumers and just the average everyday person that these are good and that these are a more sustainable alternative, because people want to help the environment and they want to do good for Earth. So if we get them on board, then we will get our community on board, and then we'll get our government on board, and we'll get the funding that is needed for this to take off and go and be as great as it has the potential to be. So we are in the right direction, and we are almost there. We just need that little extra push. Yeah, so we just need that extra push, and biofuels and second generation biofuels have a slow process, and it's slowly starting to take off, but we are headed in the right direction, and I think second generation biofuels are the future, and I think they will really help with us trying to achieve a sustainable world.
Our vision is implementation of algae-based biofuels. So you may be wondering what this means. And since many of you are not familiar with this alternative, algae represents a unique solution to land use change and energy independence. Algae is unique in that it only requires 3 components to grow: sunlight, water, and CO2. And even within that water component, various types such as freshwater, saltwater, and wastewater can be used. So certain strains of this algae are heavy in lipids, which are otherwise known as oils. And this oil can be then extracted and refined just like a fossil fuel to give us this alternative fuel source. Now this offers a distinct advantage during the refining process, as algae oil can be turned into drop-in replacements for gasoline, diesel, and jet fuel. And by drop-in, I mean that no modifications would be needed to the vehicles like the cars, the trucks, and the planes or buses to accept this fuel. Now in contrast, corn ethanol is currently blended with gasoline to a maximum percentage of 85% ethanol and 15% gasoline, and its use is limited to flex fuel vehicles. So this makes algae-based biofuels much more versatile and can be adapted to different types of vehicles over corn ethanol. Another huge advantage of algae-based fuels is that it does not have to directly compete for the land that is being used for food farming like corn ethanol does. According to algae researcher and UC San Diego professor Stephen Mayfield, algae can be grown in otherwise unused land like deserts and even wastelands where nothing else can grow, because the algae has adapted over time to these harsh conditions. By shifting production towards algae and away from corn, this would ease the strain on land competition that is currently occurring in the Midwest for corn ethanol and allow farmers to go back to focusing on food crops. So lastly, by implementing algae-based biofuels, CO2 is actually going to be consumed during the growth process through photosynthesis. And these processes are also not heavily reliant on large farm equipment like corn, which we all know contributes to excess carbon in the atmosphere. In fact, research by the U.S. Department of Energy shows that even co-locating some of these algae farms next to traditional fossil fuel plants is possible, so that the CO2 from these traditional plants is absorbed by the algae, and the algae growth is further stimulated. So it's through these advancements that is our vision that the algae-based biofuels will replace traditional corn ethanol production that currently resides in the Midwest U.S. And this will provide us with a more sustainable energy solution for our transportation needs, but will also prevent future land conversion from happening, as what's going on with corn ethanol currently.
Within the next few years, the technology used to farm, harvest, and convert microalgae to biofuel will greatly improve. This will mean greater yields at better rates, which will greatly affect the fuel market in the United States. There are different methods of cultivating microalgae for biofuel. For example, there is the algae raceway pond system, which uses paddle wheels to circulate and mix nutrients and algae through the channels. And there are photobioreactors, which circulate algae, CO2, water, and nutrients through tubes to increase the rate of photosynthesis in algae by increasing light exposure. These methods will help expand microalgae production to more areas, as terrain and land fertility aren't problems to consider like with corn or other current biofuel crops. This will all help in increasing its production within the country. When the microalgae biofuel becomes easier to produce and easier for the masses to access, the policymakers will all be able to start increasing the amount of biofuel in our fuel system, pushing fossil fuels out. With a manageable cost and its environmental benefits, the government will be able to encourage its use by the public, as it would reduce the dependency on foreign fuel imports. As biofuel becomes more widespread, it will become more popular as people will spread news about its benefits. And as the biofuel becomes more popular, fossil fuels will slowly become part of the past. The government and policymakers will probably start encouraging people and businesses to use the biofuel by giving them tax breaks like they do for charities or solar power. This will help incite more people to use biofuel as well as reward those that already do. More money for the people, less pollution in the air, and everyone is happy.